All right. Hello, everybody. Welcome to the third Iowa virtual training session on Iowa template standards. My name's Sean Searslin with the Iowa DOT. So before I hand it over to Pro Miles, I have quite a few things I want to quick cover myself. Let me just quick share my screen. All right. Couple things set up here. So if any of you haven't already heard my presentations, just a bit of background. To help the LPAs use BRR, we have a major research project going on right now to model Iowa's standard bridges in BRR for you to be able to take and use and adjust as needed for your specific bridge. So we won't have every standard modeled, but we will have a lot of them all the way back from like 1914 to I think we got up to 2017 in this research project going on right now. So this is going to include most of all the truss standards as well as the RS and V steel standards, the H pre-stress standards, and the J concrete slab standards. Um, there's also a lot of culverts and things that we couldn't model every single standard for the sake of this project, but we are going to provide an example of a B standard, a pre-stressed concrete slab, or not concrete slab, a box beam, as well as a CMP, which we talked about last week, and then a triple, a twin, and a single reinforced box culvert. So first, I just want to quick show you where you can find this stuff. So if you go to our SIMS homepage and you scroll down to resources, that will take you to here, and then not quite halfway down the page right now, we have the BRR Iowa standard templates. So this is where we have our training. We already have the recordings for the first two trainings up here. And then right here, this third one, training material, that's all the tutorials that we've been using for the in-person and the virtual training. So you can download those. Skip that one for now. So these system files and library files, so that's kind of some documentation that one of our consultants put together, walking through how to download the system libraries, the system files and libraries that we've created for this research project, as well goes into the detail of what those system files are actually changing and what the library files are actually all including. The templates themselves you can find here called BRR templates. We don't have a lot in there yet, but we're going to slowly get more and more as the year goes on. Similarly, every template has supporting calcs. Those are the hand calcs that for the material outside of BRR, such as calculating the diaphragm weight and stuff like that. It also has the controlling ratings for each element in that bridge. We wanted to make sure you had that so that you could use it as a comparison tool. So when you run the model, you should be able to take this template, if you have the system file set up, analyze it, and get the exact same results that they got in these supporting calcs. The library and system files here, that's where you can actually find our Iowa specific libraries and system files for you to download. And then I want to talk about this TR 832 status on template completion that I've created. So this is where I'm kind of tracking what we're doing, what we've uploaded so far. So you can see here I have the date, and then here's all the documents we uploaded as part of that date. If for some reason we had to make changes, I've put in void and replaced. So then you can go to the new date here, and you can see not only the new template, but I also tried to include what was changed. So you can decide if it's something that's going to impact bridges that if you've already used that standard, if it's something that's just documentation that maybe is fine if you don't update it, or if it's something that is going to affect your load rating and you want to go ahead and update your bridge as well. So that's where you can find them. For the libraries, I won't go into detail of everything we've added there, but just so you know, we have curbs and rails from various different, all the different standards, any curb and rail used in there. We have a library item for that, similar with material properties. We also have pre-stressed beam shapes. We have the A, B, C, and D beams for now, because that's what was used in the standards. But we are going to get the bulb Ts, the BTB, BTC, BTD, and BTE beam shapes in there for you too. And then we also have the truck libraries with all the Iowa legal and permit trucks that we're currently using. Um, for the system files, I won't go into all the details there, but I just want to point out the different analysis options we have. Um, so if you go to the analysis options, so we will have an ASR, an LFR, and an LRFR with all of our trucks in it for you. We will also have an LRFR, all systems overweight. So most of the time you probably won't need this. Most of the time you can use the legal trucks and just see if the factor is greater than 1.12, and that should cover all the all systems permit trucks. However, since LRFR does have different live load values for a permit truck versus a legal truck, in some cases, depending on the ADT and the size of the bridge and the vehicle and everything, it may be more beneficial or more conservative to use the permit values. So that's what this is. It's the all systems vehicles treated as permit trucks to help you get those rating factors. And then the other one we've created is this Iowa DOT LFR ASR MEM Alt. So this we are using for the research for standards that have steel superstructures and timber decks. So this has, instead of having to run an LFR analysis separate from an ASR analysis that is set up, so as long as your stringers are defaulted to run LFR and your decks defaulted to run ASR, you can run them all at once in this one analysis. So it's just to save you a little time. So those are the 5 different analysis options that we are going to provide. Just to point out, for the sake of this research, we didn't want to assume anything on your guys' behalf. So all the EVs and the permits are conservatively multi-lane, full impact, no reduced factors of any kind. It's really just a baseline. So for your individual bridges, if you want to make adjustments, add restrictions to your permits, you can certainly go ahead and alter the template, the analysis options for yourself as you wish. Just so you know, for the research, it's all very conservative right now. And then the only other thing I want to say about the systems files is we are actually going to add a couple new fields. So there will be a new system file getting updated here soon. We had a very valid question on if a template gets changed, which inevitably some of them probably will, either due to an error we find down the road or there's some new thing in a feature in BrR that we want to take advantage of, we'll probably have to update a template along the way. And so someone was asking if we already have a bridge using the old one, how can we track what version of a template that bridge was modeled off of? So we are going to add a couple more fields here to help track that information. All right, so we have the standard template used and version template used. So these fields are going to be for the DOT only. We'll put them in each template. We'll have listed the name of the template. So when you rename it, you don't lose that information. And we'll also have the version of the template, so that will have the date. I'm probably going to try to match that date to here in this status document that I just showed you earlier, just for consistency to help you track the changes in there. So those are going to be fields that we will provide. And then we also thought it might be beneficial for you guys to be able to track modifications you make to a template or to a bridge based off a template. So we'll have date last modified by, and then comments on the modification. So if you do a bridge for deterioration, a standard bridge for deterioration, or it's a standard that's been modified at some point, you can go in here and say that you modified it and maybe just a quick um, explanation on what that modification is. I don't think you can get too detailed in these lines, but just something to help you know what the changes were for. So that's something that's coming, and we'll get that to you as soon as we can. And then I have a couple more quick things. I just want to talk about templates in general and some of the assumptions we made, and then I'll pass it over to ProMiles. All right. So first, I've said this in every virtual training, and I'm going to say it again. Your bridge ID and your MBI structure have to be unique. So FHWA numbers are fine, but for your bridge ID, some different counties have the same bridge ID. So we're suggesting either put FHWA number for both these fields, or if you really want that bridge ID in there, make it something unique, maybe add in the county or the city or name or something, so that we don't have people trying to get multiple bridge IDs of the same name in there. Another assumption we had to make was the ADTT. So we just assumed 9999 to be conservative. So you might want to adjust that for your individual bridge. Another thing to consider is a lot of standards have different revisions over the years. So some revisions we thought were large enough that they got their own separate template, but some were close enough to the original that we decided to make one template using the most conservative value. So that's just another thing to keep in mind, that if you're using a standard, it might not match exactly like this if we decided to go with one of the more conservative revisions of that standard. A couple more things. When we made these models, we set them up to be analyzed for line girder and non-standard gauge analysis. However, we did not look into setting them up for a 3D finite element analysis. So they will, we did check 3D just to make sure they were running, there was no bugs, but when it comes to like 3D supports and that kind of stuff, we are not guaranteeing the accuracy of the model. So if you do want to do a 3D, please review the model a little more thoroughly. So you also might see for some standards, we have multiple rail shapes. So if it's an open rail or a barrier rail, we tried to provide both of them in the components, but if you open up the actual rail shape, we typically always use the barrier rail. Another thing I want to point out is that we decided to not link members. So if you make a change to any girder, it will not affect any of your other girders. Another thing I want to point out is the live load distribution factors. Another assumption, we decided to go ahead and not include the live load distribution factors in this field here, and we are letting the program auto-calculate those during the analysis. So most of them should be blank. There are a few exceptions where, based on where the stringer hit versus the curbs, it auto-calculated to 0. And in those cases, it will not run unless you manually enter something. So some cases you can manually enter input 0, that's fine, but you do have to manually input something. So if you do see some values here, that is probably the reason why. So that's all I want to share for now. I might have some more comments later based off of specific template types, but I think I'll pass it over to ProMiles at this point. So thanks, everybody.
Okay. Thank you, Sean. And I put a note in the chat if you have any questions, you can place them in the chat and we will try to get to it as we go along. So with that, Carolyn, I will pass it over to you.
All right, sounds good. Thank you. All right, so I think y'all should see my screen here. Um, so we're gonna start out kind of going through. There were a few tutorials that were sent out for steel, pre-stress I-beam, and RC slab templates. What we're going to cover here is we'll show kind of how to import, save, export, how you can kind of work with those things, as well as how you can update and modify that template to reflect the actual bridge that you're rating. Um, so I think to get started, we'll start with the steel template. So once you open up BrR, you'll have the template files. Once you download all of those files off the Sims site where that Sean pointed out earlier, it'll save those files to some location on your PC. So then when you go here, when you're in BRR, you can basically hit this import button and select the template that you want to use. Before we do this, I'm going to actually just briefly go back over just how to import the library and system stuff. I know we talked about that a little bit in the first training, but you'll definitely want to make sure that you have all of those system files and library files imported when you're working with these templates. So the first thing is from the Bridge Explorer window here. So when you're not in an actual bridge model, but you're in like your database of bridges, basically your Bridge Explorer, you just click this Bridge Explorer tab, and then you go over here to import, and then navigate to the location where you have all of those files saved that you downloaded from Sims. And since I'm importing here from the Bridge Explorer, it's going to give me the option to import the system data file. So that's the BRSX extension. So you select that system file and click open, and you'll see this window here. And so this includes all of the different things that are in this file. This is, I think, a little bit of an older one, but we have analysis templates, as well as some other system defaults in here. So you can just click on the system data, and that is essentially selecting everything in the subfolders, and then click this arrow, and you'll see it'll populate this with everything that it's going to import. So this also includes like county names, custom agency fields, things like this. You'll click import. Now I did already import this, which is why it's telling me it can't re-import some things, but I just want to make sure everyone kind of knows where to go and how to do this, because it is important to just make sure that you get your system data imported and set up. So once you do that, you'll get a message saying import was successful. And then you can close out of here. So again, this is the import location for the system files, and then for the library files, you're going to come over here into the View tab and Library. And once you open up the library here, you'll go back to this Bridge Explorer here in the top left corner, come back into Import, and since you're in the library now, it'll allow you to import the library files. And this is the BRLX file extension. So again, similarly to the system file, we just select the one that we want to import, click Open. And then again, you'll see the different elements that are included in this library file. So we have like vehicles, appurtenances, materials. But if we just select everything and then click import, it'll import. Again, I already have these imported, so it's going to tell me no, since I already have them imported. But this is the process to get the system and the library files set up in your system. So once you've done that, then you'll be able to then click in the library any of these different fields, and you'll see the items that were imported. So these are standard vehicles, but then you see also the agency field vehicles here. So these are all these vehicles that are set up, and then you can again you can look at the information, see all of the the properties and information about all of your library items that have been imported. Again, same with like beam shapes and other things that are in the library. You can view them all from here. So, um, all right. So, yes, and so I know we talked about that a little bit in the first training, but just wanted to briefly go back over that. All right, so now to work with the template models themselves. Um, I know there's a few different import locations here, which is why I just wanted to kind of differentiate. But so this import right here in the Bridge Explorer, the one right here, just in the top left, this is where you can import your bridge files. You can also do a batch import if you want to import a whole bunch of them at once, and that'll allow you to just select multiple and import. Um, for the purposes of what we're doing right now, we'll just do this steel bridge. So this is the V1670 250-foot template. So we'll select that one and click open. All right. So once we've imported the template bridge, this first window is we'll see the bridge model that actually opened up in the background, but this first window is also going to open right on import. So the first couple of things to look at here is like Sean had just mentioned, the first thing you're probably going to want to do is rename this to your actual bridge using like NBI and actual bridge ID. And so what we're going to do then is basically modify this template to reflect the actual bridge. So for the purposes of this example, I'm just going to rename this to example bridge. But that would be like your NBI ID. Um, all right. Now, the other couple of things just to point out here. Um, like Sean had just kind of mentioned a few things to update in this tab, but when you're in here, you will want to also review the information here in this description field. So this is going to include assumptions about how this bridge was modeled. Like we talked about a little bit in the previous trainings, there are also these documentations that were created that go along with each of these template models. So aside from the controlling ratings and everything that you have here for this is like for the unmodified template, the assumptions that are noted in that description window are also noted here in this documentation file. So you will want to review those just to make sure that that you know what's already modeled so that you can update it to reflect your actual structure. Um, and then, like we mentioned, there'll be a few other things to update in these tabs. So like the county names, these get imported when you do your system file import. So you should be able to set that. And then bridge alternative is set up. We will talk about that a little bit later. You probably don't really need to use global reference point. Like Sean mentioned, traffic is set here, but you can change it if you want to. And then we have the custom agency fields. So right now, this one just has the city here. But like Sean mentioned earlier, if when there are the additional fields in here, some of those will be DOT only to modify, but you will want to review and fill out any that you need to here for the template that you're modifying. The last thing to point out with this window here is this template checkbox. So this is basically indicating that this is, when we've imported the model, it's a template model. It's not a real in-service bridge. And so you're going to want to uncheck this for when you're taking this template and modifying it into a real bridge. This is important to do because like template bridges, for example, are not included in batch analysis when you run the batch analysis from Bridge Explorer. So this is basically indicating to the software this is not going to be a template now. This is a real bridge and should be included in the analysis. All right. So once we have made those changes, then you can go ahead and click OK. And then again, Sean, if there's anything else that you think of that you want to add as far as on this, as far as things people should make sure to fill out in here, please feel free to jump in. But I think we've covered most of it. Okay, so all right, so we click OK, and I already have a bridge with that name. Okay, we'll just, sorry about that. Okay, alrighty. Okay, so there's a few things that we'll want to do once you've got your template imported and then kind of renamed and updated here in the bridge definition. And again, just to mention again, this window will open up right away when you import the bridge. If you close it out and want to go back and make changes, you can reopen it by double clicking here at the very top of the tree in the bridge workspace. All right. So, in this template model, like Sean mentioned before, there are different versions of this bridge modeled for the different SKUs. So one thing that we're going to want to do is to set this bridge up to choose the SKU that for the actual bridge. So for this example, we're going to do the 30-degree SKU. Now the bridge alternative here essentially tells the software what should be included in the analysis when you run batch analysis. It tells the software what superstructure definitions should be included in there. So in these template models, the bridge alternatives are already set up for you. So you shouldn't need to like create a new one, but what you will want to do is set the superstructure definition so that it maps to what the bridge really is. So for this example, this is set to the 0-degree SKU, and we're going to do the 30-degree SKU for this example here. So I'm going to
Carol,
change that. Yes.
before you go on, there was a question in the chat that maybe we could answer now. It says, once we unselect the template option, do we need to click the bridge completely defined option? Does it make any changes if we select it or not?
You do not need to select that. I don't know the exact history on that bridge completely defined. My understanding is that checkbox is there because it was requested by DOT at some point, over the course of the development of the software, and I believe that it's used as like an informational thing, and so just depending on the workflow in that state, you can use that to kind of indicate if if it's preliminary or not, or if maybe there are components of it that are modeled outside the software. So I think different DOTs use that checkbox for different things, but it shouldn't change anything about the way that your analysis runs.
Okay, thank you.
Thank you. Yeah, good question. So, and I'll just go back and just real quickly show that again since we're talking about it. Yeah, this is the bridge completely defined checkbox that we're talking about here. So that's unchecked, and you can leave it unchecked if it's not being used for anything. So, okay. All right. So to select the superstructure definition that we're going to assign to the alternative, for this example, we'll do the 30-degree skew. So you can see here this structure alternative, this name is generated here and it's set to the 0-degree skew one. So we'll double click that and then select the one that we want and click OK. And then you'll see that this updated to the 30-degree skew. So now then what we can do is we can delete the superstructure definitions that are not being used so that, we've got the model reflecting just the real bridge that's actually there. So to delete the superstructure definitions that we're not using, you can just right click and then click delete. It'll ask you to confirm and then you can delete it. Now, if you try to delete the one that is assigned here, it won't let you do that. So it's saying it's being used, it's used by another object in the bridge workspace. And the reason it's not letting me do that is because this is now set as the superstructure alternative here that's like the existing current bridge. So that, if you ever do see that message, you'll probably want to double check and just see which one you have set here. So the ones that are not, saved to the bridge alternative can be deleted just to, streamline things in the model so that the model reflects the real bridge. All right. So, so that's kind of the second main thing. Like we said, first kind of main thing is to set up the actual bridge definition tab for that structure. Then the second thing is this bridge alternative here. And again, this is really, really important just because, one of the things that, aside from just running the initial rating analysis in the software, the ability to do batch analysis and analyze groups of bridges at once is really helpful for permitting and for a lot of other things for DOTs. So it is important to just review and make sure that the bridge alternative is set to the superstructure definition that you want, so that the file can be used for the batch analysis and everything. All right, so once we've gotten that set, we can go ahead and expand the superstructure definition and just take a look at the bridge that's modeled here. Again, you will probably want to reference the supporting documentation here, because this includes a summary of like the assumptions that are going into this model, the loads that are in there and stuff. So, when you're reviewing your bridge plans, you'll want to confirm what's in there and anything that's different than your real bridge. And then we'll show you in just a minute here how you can update it for things that are different for your real bridge. So once we set this to the 30-degree skew, we can see in the framing plan here, we've got our bridge right here. And then we've got the typical section. And so we can see here, there's like a parapet and barrier rail. And then we've got the travelway defined here. And again, these things are kind of set in this superstructure typical section here, where all of these parapets and rails get assigned to the bridge, as well as like, your travelway getting set here in the lane position. So, um, so for this example, and this is from the tutorial that was sent out along with this model. But for this example, we're going to show how to change if you, let's say, a standard bridge has like a parapet and rail, but the bridge that you're analyzing was constructed differently for some reason. There was a modification made to that standard. And, whether it's in as-built plans or inspection data or, the information that you have, you can see that there is a different barrier on that actual bridge. So what we'll want to do is go ahead and make that change. Let's see. Oh, before that, wearing surface. That's going to be a common one. So in this schematic here, like this yellow portion, so this is showing, this is indicating the travelway. Like I said, the width of the travelway is set here in the structure typical section. A lot of times you will have wearing surface load that needs to be added for that bridge. So to add wearing surface, you'll go to structure typical section, then click over here to the wearing surface tab. You can save wearing surfaces, to the library if you want to, but for this example, we're just going to go ahead and enter it. And we will do 3.5-inch wearing surface at 120. And then here for the load case, we're going to go ahead and pick wearing surface for the load case. If you are modifying sorry, if you are modifying or adding loads to the structure, you'll see over here in this load case description window, for these template models, these default load cases have been added and set in the model, so you should be able to select from those for different loads that you're adding to the template models. If for some reason you do want to add an additional load case for some sort of load that you're adding, you can always add that here. But default load cases are already entered in the template models. So here you just select the one that is applicable, and then we'll click OK. And then we can see here in the schematic, this has been updated now. So this shows the wearing surface that was just added here. All right, and so yeah, so that'll be included then in the dead load for analysis. All right, so so like we said, the second modification we're going to make for this structure is to modify these barriers and parapets. Now, in the library items that you import from the Iowa DOT library, you will have all of these different parapets and barriers here. So if you're switching it out to, let's say there's a different type of standard rail, you can select that, and I can show that here as well. You can just select any of these, and then we'll show how to swap them out. The other thing I want to show though for this example is that if you do run into something that's not in there, for this example, we'll just go ahead and quickly create one in the event that you need to do that. One second here. All right. So we're just going to say this is some sort of a non-standard barrier, and we're going to create it.
Yeah, and while you're doing that, Carolyn, there was a question in the chat. Sean, you might be the best to answer. If you could take a look at that one.
Sure. So it's asking about if there's a sidewalk on a bridge. They said sim for simplicity and future considerations, bridge with a sidewalk is designed for live load over the full width. In this case, it is simpler and conservative to model the barriers in all loading, but apply the travel way to the full width of the bridge as well. Will the DOT have a preference on how this is handled in the models? Um, so maybe Carolyn, do you want to talk about how the travel way affects? I don't know if I fully
Sure.
understand the question in the model, but
Ye-
DOT stance is that if you want to be conservative, we are fine with you choosing a more conservative option, but just maybe be aware of how that might affect other aspects in the model. Um, so, Carolyn, if you want to talk about maybe what changing that travel way in the
Sure.
model and what all that affects.
Yeah. I'm just gonna put a sidewalk in here just so we can look at this a little bit real quick. Okay. So if you put like I just put this sidewalk here in the model. I think what the question is kind of getting at is do you want this travel way set to come up to the edge of this sidewalk or to essentially overlap it, assuming that, a truck could actually be there. Um, so, in terms of the way that this impacts the load rating analysis, it is mainly just going to be where the vehicle is allowed to be positioned, when you're running an analysis. Um, so, um, so. So, if you do set that travel way to the inside face of this sidewalk, you'd end up with less load over here. I mean, and if you're using astro distribution factors that are based on spacing and stuff, that's one thing. But then the program will also use lever rule when it's appropriate, or if you're running 3D analysis. There's a number of different ways that the program can compute this. But essentially, it's just how close you're letting that vehicle get to the exterior girder. So. Um, so I guess that's the way that the program looks at it. I think, it is, I think, sort of an engineering judgment thing. I guess in terms of, if it's a mountable curb and a vehicle could get up there. But yeah, it could potentially impact your rating on your exterior girders. Uh, But this, yeah, like I said, this would be sort of the more conservative way to do it, where you put that sidewalk in and it includes the weight, and then it also includes the possibility that a vehicle could be located there. Um, so, um, yeah, I mean, I think that's really kind of the only you know, difference that would make it in the program. But I mean, I think it is kind of ultimately an engineering judgment type of thing for like for that particular bridge. If there is a possibility of a vehicle being located there, um, that would be something to consider. Um, so, was there any other information I can provide about that, or
I think we're probably good.
okay,
Matthew, if you have any follow-ups, let us know.
yeah. So, um, all right, yeah, good question. Good question. All righty. So, Oh yeah, and one other thing to mention too, and I think we'll show this maybe a little bit. I can try and show this a little bit later too here in the tutorial, but I'm that's a good question, and I'm glad that you mentioned that because the other thing too is that if you do have, let's say, even just different barriers or something here, you will want to potentially recompute that travel way. So in the example that we're going to do right now, we're going to change out the barrier, but then, if that is, let's say, a narrower or wider barrier, you would want to also update the travel way width here to um, reflect the actual lane positions where a vehicle could be located. All right, so to switch out this parapet, basically, I came in here and just created this new barrier. Again, you also can, select one from the library if it is a standard. So then we're going to come back in here to the typical section window again, and we'll go to the parapet tab. So now since I've saved this other library or not library parapet, the new parapet here, it'll be selectable when I click this drop down. Now, same with, if you wanted to use a library one, you could do copy from library and um, let's say once we select this one, that gets added here. So that item is now copied to this bridge model as well. And so again, it'll be selectable here and you can swap it out. All right. So to change out this parapet, we'll come back here and just select the new one that we created. Um, Again, this since these are aligned based on like the back of the parapet, I shouldn't need to change anything here for this example, but you will want to kind of just look at that as well. When you click apply, the schematic will be updated to reflect that new barrier. So that's kind of a good way to just double check on, if this is set up here. If you see a parapet that is, let's say, backwards or in a different position than you're expecting, these fields here are probably the first place you'd want to look to update that. And then anytime you make a change to that and click apply, this schematic will update as well to reflect it. All right, so we have changed out that parapet. Now the railing, we can go ahead and delete the railing too, because that railing went with that other parapet and it's not there for our real bridge. So we click apply, we see that go away. So So we've been able to swap those out. Now, one thing that I want to point out is, again, these are like the same width, but if they were not, you would want to also come back in here, go to lane position, and you can use the compute button. It'll position the travel way, in between your parapets, or you can just manually enter what you want that travel way to be. All right. So let's see. So another maybe somewhat common scenario that you might run into is just other added loads to that structure um, that are that are not in the standard. There's all kinds of things out there like for like an attached utility pipe, for example, or other loads that are not already accounted for in the model. So the software will use all of these elements that are modeled here and compute the weight of all of those. So girders, deck, parapets, wearing surface, all that other stuff, all of that dead load will be computed by the program. But if we want to add like an additional load that's not included in any of that, we can do that here. And so for this example, we'll go to the member loads tab, and we'll just create a new load here. And then select the load case. Again, these will be available based on what you have set in the load case description window. So again, if you do need to add some kind of other load case for some load there, you can go to this load case description, add it here. And once it's added here, it'll be selectable in this window. All right, so that we click OK, and so that that adds that load here. I'll go ahead and do it for this girder as well. The other thing to point out here, so in this example, this would potentially reflect, like, let's say you have a utility line that's between these two girders and like attached, bracketed or something like that. So we have like part of that weight going to one, part going to the other. So that's why we're going to enter that for this here as well. Sometimes you'll see that there are loads entered in the template model already. So like in this case for girder 2, you'll see this additional deck thickness for uniform load. And again, if you ever, I think most of them are they do say there is a description of what they are, but you can also refer to the documentation, the template documentation as well, and this will have information about added loads in the models that are already included there. So for this example, we're going to keep that in there, and we're just going to go ahead and add a new one. All right. So we have added those loads to both of those first two girders. And then I think one of the other things that we'll want to cover here is deterioration. Now this is going to be a little bit different for different bridge types. So we'll go through and show you here for steel, and then I'll point out the couple ways you can do that for some other structure types as well. So for this template, basically we're just going to expand the member alternative that we know has deterioration. Into girder schematic. So the schematic will also reflect deterioration when it's entered. Right now, it's just a label since there's no deterioration, entered in the template. All right. So we open up the deterioration profile window. And so for this example, we're just going to go ahead and enter deterioration for, I think, the web and the bottom flange. So I'll just do that here real quick. And then we can take a look at how this will impact the model. All right, so apply basically just saves it and keeps the window open. Okay, saves it and closes the window. But we want to do another tab here. So, so the web, and then we'll go bottom flange. And then we'll do uniform we'll do the thickness loss here over the bottom flange. One thing to keep in mind is the program does let you enter deterioration here for flanges for using percent width and percent thickness. And I know sometimes just based on um, inspection information, you'll just make those determinations as accurately as possible. The software does use the modified values when it's doing all of the AASHTO checks. There are quite a few checks that look at, width and thickness to look at the potential buckling of those flanges. So just keep in mind that, like, as you're entering deterioration, the the software is doing all of the AASHTO checks, and so the width and thickness here can, in some cases, have a pretty big impact, especially if it's a compression flange. So um, let's see here. Okay, so we got the bottom flange, and then we're just going to do the cover plate, and then we'll do. Right, so. mm, Sorry, yeah, it's okay. All right. Okay, so we'll go ahead and do that, and then we can see here we've got um, the deterioration that was entered. So we've got bottom flange deterioration along the bottom of the girder, and then we've got web deterioration and bottom cover plate deterioration in certain locations. Um, all right. So I think the one other thing just to point out, like I said, this assumes, a percent width, percent thickness, and that's then used to modify the properties that are used in the AASHTO equations for all of the different spec checks. Sometimes you may run into um, some type of a situation where you have deterioration that um, maybe wouldn't necessarily best be modeled that way. If you do run into a situation where you have something really unusual, there's also this points of interest window. So we're not going to make any changes here for this example, but I just want to point it out. What this does is it basically allows you to create analysis points that that you can change and adjust these values, and you can override capacities if needed, and you can override a number of other things here as well.
Carolyn, there was a question in the chat. Is there any plan to include web crippling checks for deteriorated members? The current entry for web SL is very general, and when we typically see concentrated SL at the bottom of the web. So the question is
Okay.
about web crippling checks for deteriorated members.
Yeah, that's a good question. So off the top of my head, I know there was something we were looking at recently with okay, there was something we were looking at recently with just some kind of basic AASHTO checks for web crippling. At the user group meeting last year, there was quite a bit of discussion about that topic specifically, as well as other types of more advanced deterioration modeling. It's definitely, because sometimes too, you'll see even aside from, a lot of times on webs it's not uniform. I mean, sometimes you may have, quite a variation in thickness and all that other stuff. And so there has been a lot of discussion and a lot of interest, I think, in adding some more refined ways to evaluate those types of situations. Um, I don't know I can't say for sure when that will be available, but from what I understand, it is it's definitely on the radar, probably for a future version. Um,
Okay.
so yeah.
All right. You're
Alrighty.
welcome.
Yeah, yeah, good question. I know that's definitely uh a pretty common thing that you'll see with bridges with that type of deterioration. And so yeah, in that kind of a scenario, if you you know, if you are running into something where you're like you do need to come, or if you run into something that you you know, need to evaluate in a way that the program doesn't cover, you can enter that information here in the point of interest override. Um, all right. So that basically covers the kind of some common changes that you may make for a template model. Um, the last thing we'll do here, I think, is just go ahead and run this and take a look at a couple of things here. Um, so I think let's look at maybe an interior girder, and we will just go to we'll select what we want to rate. Actually, well, I just did deterioration here. All right, let's do this one. All right, so we'll go select the order that we want to rate. Go to analysis settings, and we can open the template for Iowa DOT. We're going to do this one LFR. So we'll see all the vehicles populated here. And then we can go ahead and click OK and analyze. So this is running the analysis. You'll see like information messages here while it's running. This one takes a little bit of time because it's a little bit of a longer bridge and we have a lot of vehicles in the template here, but this should just be a moment. All right. So we ran the analysis there, and in the first place we want to probably check is tabular results. Um, Switch to single rating level per row. Um, and so here we'll see controlling rating factors. Now, let me see here. All right. So if we look at the documentation for this template, we can see like exterior beam rating, so G1. Um, and this basically includes the rating factors for the unmodified template model. So this is what these rating factors come out to before any of the changes that we made. And if you want to kind of, I think this can be kind of a good sanity check in terms of, you know, assessing changes that you've made to the model, is to, you know, look at how you know, the changes actually, you know, affect the results. So in this case, we can see that the rating factor did drop, which is to be expected since we added some wearing surface dead load, and we also entered some deterioration. Um, we can see that we still have flexure controlling. Um, and let's see. Okay, so then we've got tabular results there, and then again, you'll probably want to also review the spec check detail. um, Again, this is you know, if you do, let's say, get a rating that's controlling and is maybe not what you're expecting, or even just, you know, just to review what the program is doing, just regardless. Basically, you would want to kind of identify the location that you'd want to see. You can come in here and, you know, go to those locations. Um, and for each of these locations, then you can open up the the spec article. Um, and basically review all of the checks that are being done, all of the loads that are included, And then the section properties here as well should reflect the change any changes you make for deterioration. So for example, this is in like the end section here. Too many too many windows. But so this and at this point here is 7.625 feet. So that's within this section here where we've got some deterioration entered. And we can see here that the bottom flange reflects that. And so this can be a good place to look to, really kind of confirm and assess how that model is behaving based on the changes. And I think a lot of times too, particularly when you're looking at modeling deterioration, it is definitely important to kind of really think through how you're modeling it and how that's going to be used in the analysis, just to make sure that it's capturing that the way you want it to. Like I said, changing those dimensions here to reflect deterioration will modify the values that are used, that'll carry all the way through the AASHTO spec checks. So like I said, you can see it here in section properties. But again, as well with these other articles, you'll be able to kind of see how that's working, especially when you do run into a situation where you have deterioration that's causing a low rating. This is where you can go to basically verify all of the values that are being used and the specification checks that are being done. So these all correspond with the AASHTO spec reference, and then you also have like the MBE rating articles. So again, these all correspond to the AASHTO and MBE. So you can look here just to verify what the program is doing. Let me see here. Um, all right. So, all right. So I think the other thing now to cover with this as well is, so like I said, we imported this bridge as a template. But when we first imported it, we changed the name, we got rid of the superstructure definitions that didn't apply, and then like updated it to reflect that real bridge. So now this bridge model is, the bridge model. And once you've, done all of your QA and checking and everything, and you're happy with the model, you're going to want to be able to export that model and send it to your agency, um, or send it. I mean, there's if you're like a local agency or consultant, you may need to send it to DOT. So in terms of exporting the model, that's the next thing I'll show here. So all right, so we'll hit save. You will, when you go to save, you will see a bunch of stuff here. A lot of these are just informational messages. And so, like I said, this is like the distribution factors not defined, like Sean mentioned earlier. Iowa DOT is letting those distribution factors compute at runtime, so that's fine. But this is just informational messages. That this error route number is not defined is currently shown as an error, but that one is fine as well. So we'll continue saving. So we've saved the model. And now we want to export it. So I'm going to export this bridge, and you'll see that this file is renamed. It's giving it this bridge number, but it's naming it to the name. It's using the name that I changed this to. So when I go to export and then save, basically that will export that XML file. And let me just give me 1 second here. Okay. So then you'll see here, so this is the bridge that I just exported. So this it just assigns it this number and then this bridge one. So this will be, your bridge name or your NBI number. Really is what this will be. So once I've now exported this model, the real bridge model, we'll see that this gets saved here. So this is a different file from the template models. The templates, the XML files, um, basically, you just remain. So, you can use those, import them. But when we imported this, we brought it in, and changed it, saved it, and then that basically made it its own bridge. Um, and then again, to then import a model that you've made, it would be the same process as with the template. So you can now then, if you need to share that file with someone, you can send them this file and they can import it and they'll have your bridge model. Um, all right. I think, um, I think that this covers, I think pretty much everything we had here for this steel template. We do have a couple of other templates here for pre-stress I and RC slab. Some of those tutorials cover very similar things, so we probably don't want to go through the like exact identical parts, but there are a few differences with those that I think we will take a little bit of time here just to go through and look at. Um,
Hey,
but
Carolyn.
yes.
Since you showed how to export, would you also mind just showing where in BRR, when you saved it, where it went, and if you want to make like different folders, maybe if they have multiple counties or something, um, how they can best utilize the folder structure to put these
Oh,
bridges?
sure.
Thank you.
Yeah, yeah. Thank you. I'm glad you mentioned that. All right. So this has been saved here, and I'm gonna close out of this. So this is the bridge one that, well, I don't even need to close out of it. This is bridge one that we just saved. So this is gonna get saved here into the database. Now I have a lot of different stuff in here. You're probably gonna see these example bridges that'll go through about 32, and then you'll see bridges that you're creating in the list after that. So ignore all of these other bridges. But the bridge that I just got created was created right here. This last one in the list. And so that's our bridge here. Um, as you start to build up bridges in your database, you may want to make use of these folders to try and kind of keep things organized. Um, in the first training, Jeff talked a little bit about how these folders work. And so I think you can you can review that as well. The one thing that I think is the one thing that I think tends to be a little bit confusing about the folders is that they're really more of like a filter than a folder. So it's not going to like move that bridge out of your main database. It's going to kind of just provide sort of a grouping for it, so that it can help you to keep track of certain ones more easily. Um, So you can, when you want to go and create new folders, you can create a new folder. Um, and then you've got a few different options here on, um, you know, filtering to kind of add a list of bridges. So, for example, you could use a location list and a particular county. Um, and and let's see, we'll try this. Here. So here I basically just selected unknown because I figured I'd have at least a couple of them in there. So then I go to find now, it'll tell me those ones. So if you wanted to say pick a particular county, you could pick that county, find now, and it'll get you the list of bridges that have that county saved to them. There's also a few things that you can do here with the other attributes that you can use to kind of sort and filter. And so once you've got that, you can do like save folder. So I just put this folder here just as an example. But again, keep in mind that this really is sort of a filter rather than a folder. So it's not copying these bridges to any new location. They're all still in my main database. This filter just or folder just allows me to more easily find a particular group of them. So we've got bridge IDs like 2, 30, and 65, and we'll see those still those same bridges in the main database, but the folders can help you to narrow that down. Um, and then again to go back to the bridge, and here I'll close this out. But to go back to the bridge, this was the one that we just were working with, and we can just double click to get back here. Um, so yeah, so I think that mostly covers that. Um, are there any other questions here? I'll just take a second and get the next one opened up here, but let me just check and see if we have questions. Where is the default save location and can be changed to a shared folder for multiple teams working in different offices? I could let me think about this. Um,
I mean, are you talking about the save location of the XML file? I mean, the save location is the database. Things get saved to the database. So it depends on how your database is configured.
yeah, there's a couple of things there, and I think that is really probably the best way to answer it. I know there are states that do use shared databases. That I mean, that is something that from what I understand, I don't think IOD is doing right now, but yeah, you would need to have a shared database set up. Um, and then if and then there are some things, I guess just the other thing to mention with that as well. So as far as that shared location, and this is a little ways out still, but we are working towards getting BRDR into the cloud, and that'll involve a number of different things, and that'll involve a number of different changes that will make it easier for you to do things like this as far as accessing and sharing models um, with different users. We are in the process of working on this, but it is a big process, so it's going to be a little while still before we do have BRDR in the cloud. Um, we are doing cloud, or we are doing cloud hosting, or now we can set up hosted databases, and we'll be, like I said, again, moving to the cloud over a few years, which will make this a lot easier then.
Okay, and there were some responses in the chat of people that have done different things, shared databases using an SQL on a VM. And those are all, reasonable ways to do it. As far as the XML file, if the question was about the XML files, you can save it anywhere, and it's XML is just text, so you can send it or give it to anybody if you export the file.
Yeah. So, if so for this, if we when we go to save uh we can go to save this bridge. When we go to export, so this will just this you can just navigate to whatever location you want. But once you export this XML, then you can share that. Um, yeah, so this just gets saved to whatever location you choose.
I may not be understanding the question right, but I know with us with the unlimited license, if I make a bridge or I set up something, someone else within our program will see that bridge. Like if I create it, it's visible for everybody. Is that not the case for all licenses?
It just depends on how you have it set up at your location. You can have a standalone SQL license on your workstation, and you could have just your bridges there, or you could set it up so it's a shared database. Um, Typically, when it's a shared database, there are you can put some restrictions on it. Sean, I don't know if you guys use that check in, check out um, system administrator option, but there is an option to kind of lock down the database. You have to turn it on in the system administrator application, and it basically allows users to check out a bridge. And if it's not checked out, you can open the bridge, but the input fields are read only. So you can't actually modify it if it's not checked out. Do you guys, does Iowa use that?
Uh, I I don't know. I'd have to look.
Okay. You would notice it, like if you look at the Bridge Explorer where it's that Carolyn has up right now, there's a bridge ID. To the left of that would be like a check in, check out column
Okay.
if you had
Yeah,
it turned on.
I don't think we have that.
Okay. I mean, that's an option if you have shared database, and it's just a little bit of a protection to keep people from changing things without actually checking it out. So when you check it out, you check it back in, you kind of have a record of who made the changes. I don't know if that answers your question or not, but um, it can be done multiple ways, I guess, is the short answer. A standalone database on a user's computer or shared database.
Yeah, and we can yeah, and if there are, I guess, other specific questions on how to get different things configured different ways, we can certainly help you out with that, with any of that to help you get your system set up the way that you want it to be. So, in terms of getting things set up and uh, you can always just reach out to us and we can help you get things configured the way you want them. And then, like I said, a few years down the road when we were moving to cloud, this is one thing that I think, well, you'll have a lot of different options at that point. Make it easier to share and interact with files with other people in your organization. All right. Okay, so just trying to see if we have any other questions here before we take a quick look at these other models. I think we're caught up. I think we're caught up, but yeah, we got a lot of good questions here. So yeah, let me just like I said, I want to just kind of highlight a couple of things here. So the other two kind of tutorials that were sent out. One of them is for the pre-stress I-beam, and then the other one is for the reinforced concrete slab. So when you got the training info, I think those tutorials were sent out then. And so BRR is set up to try and kind of have things be similar among different structure types. So like the way that you would enter a wearing surface load for a pre-stress bridge or a steel bridge, I mean, that's the same thing for different bridge types. There are a couple of things here that I want to just highlight about other things that are different for bridge types. So, all right. So for the pre-stress bridge, we're going to go ahead and open the, hold on a second, the H template. Yes. Okay. All right. So we'll go ahead and open up the pre-stress bridge template. All right. So, similarly to the last bridge that we looked at, we are going to want to set the bridge ID for the NBI ID. And since this is, we're going to be modifying this template, we'll uncheck the template. And then, review any assumptions here. Again, this will be reflected in the supporting documentation that you get on the SIM site. We'll go through the other fields here, counties. This is going to be the same for all of the bridge types. But once we've updated the name here and template, we can go ahead and click OK. All right, so one thing to point out with this bridge that's a little bit different than what we were just looking at with the steel bridge. So this is a pre-stress I-beam bridge, and it is three simple spans, or it's modeled as three simple spans. The steel bridge that we just modeled was continuous, continuous for all structurally continuous over all of the spans. And so that bridge was modeled using one superstructure definition. So a superstructure definition basically, for this case, since these are not structurally continuous, they are modeled as separate superstructure definitions. And then in the bridge alternative, basically you can include multiple of them. So it's sort of like if you have, similarly to a bridge where you might have, let's say, a couple of different like units, like different units of the bridge. They're not structurally continuous, but are part of the same structure number. This is kind of the same concept. Since these are modeled as simple spans, that's why they are different alternatives. So we're going to go through here and just kind of go back over just the process of setting up this part of it, because again, it is really important to make sure that that the bridge alternative reflects the superstructure definitions that you're actually using for the bridge model. So this is going to be basically the same process as the one that we just looked at. It's just that we're going to have to do it twice, once for the end spans and once for the middle span. So we can go ahead and expand the superstructures that are included here. And then for each of these alternatives, we're going to select the one that reflects what we want this to be. So this is for the span 1 and 3. And we want to do this bridge as, for this example, we'll do the 45-degree skew. So here I'll select span 1 and 3, 45-degree skew. Click Save. And then I need to do that for this one as well for the span 2 section of the bridge. So I'll open that up and then go to the span 2, 45-degree skew and click OK. So now, now I've updated the bridge alternatives to match the skews that we want, both for the end spans and the middle spans. And then similarly to the last bridge, we'll just go through and delete the ones that we're not going to use. And again, it'll prevent you from deleting if it is one that you've set as a superstructure alternative. All right. Um, okay. So once we've got that set up, a lot of the changes that we're going to make here are the same as what we went over in the last example. But just to note the couple of differences is that since this structure does have two different superstructure definitions included, we will have to make these changes in both places if it's applicable for both, or only in the one that it's applicable for, depending on what it is as far as added loads or deterioration. Um, so the first superstructure definition is going to reflect the end spans, and so we can take a look at the framing plan and typical section here for the pre-stress I-beam bridge. Um, and then again, similarly, the second one here will reflect the middle span. Um, all right. Um, so similarly, to the other structure that we just looked at, your load case descriptions here will be pre-populated with defaults. You can always add new ones if needed. Um, Again, if you want to add a wearing surface, you'll do that here in structural typical section, wearing surface. Um, we'll do this kind of just quick here because this is the same as the other structure type. But but just the one thing to point out is that you like for something like this, the wearing surface is probably over, all of the spans, so you will need to enter that for both of the superstructure definitions. So we do it there for the first one, and then we'll do it here for the middle spans. Um, um, okay. Um, Now some of the standards have in the standard plans will show two different options for the railing or the parapet. This example is one of them. So in the documentation, again, it'll note, the assumptions that are made and like the ones that are used, but like you'll see here, if if you do want to if you want to change it, if that in service bridge has a different one than what's used for the template, we can do that here. So in this standard, both options for that rail are saved to the bridge model. But again, if you want to change it and use a barrier that's not already in the bridge model, all you'll need to do is just open up like uh, the appurtenance window for like generic parapet or medium, and go to the library and select it and add it to the model if it's not already in here. So for this example, we do have them in here already. So we're just going to go in here and switch these out. And since this other option here, the concrete rail, is modeled as a generic appurtenance, we'll add those in on the generic tab here. Again, it's just different, I guess, library item types for like parapet versus let's say like an open rail. And so the open rail is modeled as generic. Since we only have one component saved here under generic appurtenances, that one's automatically populated here. But again, you can just select the one that you want. And then we'll set the load cases and locations real quick here. Okay, so this basically adds the railing that we want to add, and then we can go ahead and delete the one that we want to delete. And so this should swap out our railing. Oh, there we go. All right, so I was looking at the bridge typical section here for this second alternative. If we look now at the typical section for the one that we just made the change in here, we'll see we will see that these are updated here. And again, that's just something to kind of keep in mind when with bridges like this, where you do have a couple of different alternatives or different definitions. Just again, just something to keep an eye on. Now, the one other thing to note too is again with the lane position. So if we want to go to lane position and compute, so since I changed out those barriers, it's telling me that, there is actually a slightly larger travelway now, more space between those barriers. So I compute and apply, and so this basically this applies the new travelway width. And so then I can click OK, and we see that this gets adjusted accordingly. All right. So um, you would need to then go ahead and do that again in this second definition. For the sake of time, we're not going to go through and do that. But again, when you do have the two different superstructures within one bridge, just make sure to do it for both of them if it's applicable. Um, the second kind of thing we have here, in this example is member loads. Again, this is pretty much exactly the same process here as what we showed for the last bridge. So we won't take the time to go through and do this, but this is in the tutorials that were sent out here. So again, you can open this up, add a new member load for anything that's here. Any member loads that are already in here, you can refer to the documentation that's provided with the template, make sure it's still applicable to that structure. So same process there. And again, just make sure to do it for both definitions if applicable. So now deterioration. So for pre-stressed beams, you'll see that we don't have the deterioration window here like we did for the steel beams. But a lot of times what you'll see is, spalling and damaged pre-stressing strands. In a lot of cases, once those strands are damaged, they're considered to be ineffective. And so, generally that's a pretty common way of modeling deterioration, is just to indicate that those strands are not effective. So in that case, you can just open up the strand layout window, and you can basically click to unselect any strands that you don't that you want to unselect. The other thing that you can do is you can click and drag to highlight a group of strands. And then if you right click, it'll give you the option to like remove selected strands, or add at all locations. So this will give me the option to remove that as a group. And again, if I want to add them back in, again, I can click and drag to capture that, right click, add a strand at those locations. So again, this
Carolyn,
demo is,
I don't know if you mentioned this or not, but the strands that are available there are defined in your pre-stress girder section up above that you added. There's a strand, potential strand grid layout up in the components.
yes, thank you, Mark. Yeah, so that's a good thing to note here. So um so these are imported with like the bridge and with the library, the Iowa DOT library items. So this is where the beam shape is actually defined. And then we have properties, mild steel, and then this strand grid here. And so this is where like the potential locations for those strands are defined. Um, it's probably pretty uncommon that you would need to change these for a template, but this is really important to understand for like when you're creating, if you're creating a bridge model or if you do have some kind of a beam shape that's not one of these standards, this is where you can set and modify that information. So, so yeah, I'm really glad you mentioned that Mark, because yeah, this window here really just shows the strands that are, there for that actual beam. The beam definition itself over here in the components tab is where you can check and set and change the rest of this information.
Thanks, Carolyn.
Yeah, thank you, Mark. Um, all right. So here, and this is not exactly following tutorial, but just for the sake of demonstration purposes here. So we'll remove some of these strands here to reflect deterioration in the bottom part of this beam. And then we can go ahead and click OK. So that's how we can do like deterioration for strands. For pre-stressed beams, this is probably less common, but maybe still needed in some cases. If you do have like if you do have deterioration that would impact like your shear capacity or something like that, this again, you would want to use points of interest for other types of capacity modifications. So, for example, for shear, we can do like override schedule here, and then you you set the point that you want this analysis point to reflect, um, and then you can basically enter the override information. Again, this F1 help key um, is is definitely probably important to use as you're kind of going through this. So any window that you're in, the F1 help key will pop up this window, and then this will give you some more information about how the information that's entered here in these points of interest is used in the software. Um, and so basically this will allow you to override different kind of aspects of the capacity. Um, so for this example, we're going to go ahead and enter some overrides here, and then we'll see. So here we're basically entering like a reduced shear area essentially for vertical shear. So if you have deterioration that you actually see damaged shear reinforcement as well, this is where you would set that. All right. Okay. So so basically we've set up the overrides here to reflect shear. Again, anytime you're entering deterioration, it is probably going to be important to kind of really look at kind of how the program is using the information that you're entering for any, different type of deterioration. But again, the F1 help menu is a good place to start at looking at what it's asking for with these values for these different things. And again, methods of solution, also very good reference as you're working through these template models. All right, so, and then we see here, so this created this analysis point. And we didn't make any changes over here. So like flexural capacity and all that will still be computed based on all the properties and stuff that we've entered. But we do have that shear override. Okay. So once we've got this set up, we can go ahead and run an analysis. And Do LRFR for this
Carolyn,
one.
while you're here,
Mhm.
would you mind showing if they want to make like a permit single lane or something, how they could, if they wanted to adjust the analysis for a truck?
Oh, sure. So yeah, so in analysis settings here, um, so the analysis settings templates are set up like Sean said before, just for sort of a normal uh configuration. There is this advanced tab here that allows you to um, make some changes and modify those load configurations in the event that you need to. Um, there is this checkbox here for single lane loaded that you can check, and this will basically this will use single lane distribution as opposed to multi-lane. Um, as as a little bit of a side note, so the program, so this structure is, wide enough for multiple lanes of traffic, as most are, and so in that situation, the software will, compute the distribution factors and use multi-lane, and if the structure is only narrow enough for one lane, it'll use single lane. Um, but in a case like this where let's say for some of these vehicles, if you did want to run, maybe just a permit truck, maybe you don't want to use a template, and or even if you do want to use a template, but you just want to do a permit truck, you can go to advanced, and then this single lane checkbox will will tell the software to use single lane distribution instead of multi-lane. There's also here you can adjust impact. Again, this is mainly used for permitting, where you have like speed restrictions and things like that. So so if you are doing running this to analyze a permit load, this is where you can make some of those changes here. The one other thing to mention. So, like I said, it'll use single lane distribution instead of multi-lane. Um, it will still consider this whole travelway. So, if you did want to restrict it to part of the travelway, you could either adjust the travelway, use stripe lanes, um, non-standard gauge. I know that's kind of a whole other topic, but it's this advanced options tab here allows you to make changes to how those vehicles are configured. And again, you can do this for like individual vehicles. So
Thank you.
um, okay, yeah, thank you. Um, okay, so let's see. So we got that analysis here. And again, this is going to be very similar to the one we just saw. We get our results here. We can kind of sanity check that against the documentation that's provided along with these. And then you can also take a look at the spec check and see some of the different things that are being done there. One thing to note here. So in the unmodified template, we had like flexure controlling, and now that when we made this change here, so we reduced the moment capacity using the strand reduction, and then this points of interest for the shear modification. And so as you'll notice now, it'll say location one, and shear. So this is basically saying that the what we put in there for the shear override is now controlling for this structure. And so then you can go into the spec check detail and go to this location. Um, and we'll see here, shear is indeed controlling. Oh, I didn't check the article thing when I ran the analysis. Hold on. But you can go and review there as well. Um, you can go there and review as well to look at how it's using those values.
Okay, Carolyn, we had a question about the best way to see the controlling results for the whole bridge versus going girder by girder. So if you want to see the controlling results for the rating, I'm assuming, what's the best way to do that?
I gotcha. Good question. Yeah, we get that question a lot, and we've actually had some requests we were talking about even just recently, as far as making it a little easier to do that from within the Bridge workspace. Because right now, you would want to go, you would kind of need to go girder by girder, because you select the member alternative and it'll show you tabular results. But if you do want to run the whole thing at once and see controlling results, here's how you would do that. So we made the changes that we wanted to this model, and we we got that done. So I'm going to go ahead and click save. Um, so this model is now saved here in my database. So that's this bridge too. If I analyze that bridge from here, that can make this a little easier to see. So I'll go to open template and LRFR.
And just a reminder on terminology, the place where you see the listing of all the bridges, that's the Bridge Explorer. When you open up an individual bridge, that's called the Bridge Workspace. So right now, Carolyn is running it from the Bridge Explorer as opposed to being in the bridge itself, which is the Bridge Workspace. And the kind of the nice thing about this is when you're in the bridge workspace, you may have multiple superstructure definitions. Like you might have, uh, a combination of steel and pre-stressed bridges that make up the entire bridge. When you run it from the Bridge Explorer, it's looking at all of those, and the results that you're going to get are the controlling rating for the entire bridge.
Yes, exactly. Yeah, and this also kind of comes back to highlight what this whole thing that we've been talking about with bridge alternatives. And so here, like we can see that it's including the first the end spans, and the middle, all the middle span girders. And then like Mark said too, if you did even have like different, if you had different component types within a bridge, or you had, I don't know, a separate sort of approach span and main span, all of that stuff will be included here as long as it's saved to a bridge alternative. All right, so we got that run, and then when that runs, you click OK, and then you'll see this screen pop up here. And so this, let me just expand this here. Okay, so this is it's again we did include like a lot of vehicles here, so it is still a lot to see, but it is kind of all in one place. So we're gonna look at like for this bridge, and let's say for this truck, this 136 skips. So I want to, I'm going to select this one and then go to view structure rating results. And so then this will tell you a little bit more. So for this vehicle, this is basically looking at, so here, this is like your overall controlling rating factor for this vehicle. This is saying spans 1 and 3 and span 2. So here it's basically telling you it spans 1 and 3 is controlling there. And then you can also from there click member rating results. And so this will again show you a little bit more. This is showing the exterior girder that we just made those modifications to, is that lowest rating factor, that one that's reflected here in like the overall rating for that truck. And then we can see like the other like unmodified girders have the higher ratings. So it's not quite as succinct of a format as I know some have sort of have mentioned with this. It is a lot of information, especially when you do run a lot of trucks at once like this. But there, we have had requests to be able to see something like this from within the Bridge workspace as well. But just running it from the Bridge Explorer will allow you to see this view of it. Alrighty. So I think that pretty much covers most of what we had with this one. Again, you can always from Bridge Explorer here, that's where you can see that view that I just showed you. where you can kind of see everything all together from within the bridge workspace itself. Um, if you select like the superstructure definition or the bridge alternative and hit analyze, it'll analyze everything, but then you'll still need to click on like the member alternatives individually to see each one if you want to do it that way. And then again, any changes you make here with capacity and stuff should be reflected in the spec check details. So you can always go through and review and like evaluate and make sure that like the way that you're entering that information is the way that you intend it to be. Um, so I think that covers all we had for this one. The one additional template example that we have is for the RC slab. Um, we only really have a couple minutes left here. The one thing, I guess, the couple things I'll just mention real quick. So the RC slab is very, very similar to what we just went through. It's very, very much the same process. Selecting the correct configuration. Or I'll just import it real quick, just so we can quickly look at it. But it's very much the same process that we just covered for both of these other bridges. So you'll set up this window, select the structure definitions that match your bridge, and assign those to the bridge alternatives, delete the ones that you're not going to use. Adding loads like wearing surface, all that kind of stuff is going to be the same type of procedure that we just showed. The 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 other thing here, you'll see similarly, you will have for the RC slab, you'll again have a points of interest window. The points of interest window is again a little bit different for each structure type. But for an RC slab, if you did want to do capacity overrides, this would be the place that you would do it. Kind of, yeah. So this is where you would enter any overrides to reflect um, uh, a limited capacity for RC slab. But I think a lot of the rest of what's in that tutorial, um, sorry, was covered in the ones we just talked about. Sorry. Um, so I don't know if there were any other questions here. I know we're
Yeah, one thing about the RC slab system, just as an aside, initially slab bridges were incorporated um, as a line girder type of analysis. The slab system was added probably about 10 or so years ago, and it allows you to define the whole cross section of the slab, and you can either break the line girder. I think was broken down into like a 12-inch slab. This one you can break down um, however you like. Like you can break it into 10 sections, 5 sections, 4 sections. But basically, you get to define how you want to break it, how you want to break it down. But you define the reinforcement for the entire typical section, and then it will it'll do an analysis of each of the segments.
Yes, thank you. And you'll see here on these template models, each of these slabs has three sections defined. So there's like the interior strip and exterior strips. So, um,
While you
And
still
you,
have that screen up, I'd like to just
mm,
point out some specific things for slabs. Um, you'll notice right here we have monolithic pier cap and non-monolithic pier cap. Michael Baker, who did this model, showed us both. And the only difference really is that they're putting extra thickness in that the cap and the abutment, which we said we don't need to analyze that. Just a solid uh, thickness of the slab from abutment to abutment is fine with us. Um, we did originally leave that monolithic pier cap up there in case people wanted, but we found it was confusing people more than it was helping anyone. So we did change this model and we just completely took out that monolithic pier cap. Really, whether it's monolithic or non-monolithic, you're going to load rate it the same with that just solid thickness all the way across. Um, so whether it's monolithic or non-monolithic, we got rid of that. We're just going to treat them all the same. Also, like they said, instead of the 12-inch strip, we decided to do the full width of the slab. And two other things I want to add about slab templates. Some template or some standards have an option with a sloped bottom or a flat bottom. We went with the sloped bottom. Also, for LRFD, we did do all SKUs, but for LFD, we only did the zero SKU. But I think for slabs, it's very easy to change the SKU since we don't have any transverse reinforcement or anything. Um, so those are just some things particular about the slab templates I wanted to bring up.
Thanks, Sean.
Thank you.
Okay, so we had a
Oh,
question about RC slab systems. Is there a benefit of running the slab as multiple sections versus one single section? Um, I, just in my experience, because I did some of the testing on it early when we implemented it, um, I, I I don't remember seeing a lot of difference in the rating between breaking it up into 20 sections, 10 sections, 5 sections, or just having it as one section. There are some differences, but not I don't ever remember noticing a lot of difference in the rating. And Carolyn, I don't know if you want to add to that.
sure. Yeah. Just no, I think that sounds right in terms of you should be able to do it different ways and still get, the right rating. I think part of the reasoning for doing it this way particular with like interior versus exterior is just if you do, for example, have some sort of a configuration where there's a difference in like the distribution
Hmm.
factors, or also sometimes you'll see situations where an edge strip on a slab will have kind of different reinforcement details than the interior part, so there can be some value in having that be set up as a separate section. um,
Right.
so
Yeah, and if you basically have the same rebar spacing the whole way across, you're going to have a wider section, but it's going to be the same spacing, so it's going to give you roughly the same capacity. But as Carolyn said, when you get to the exterior of the bridge, you may have spacing that's closer together, and so um, you'll have a different relative capacity. So good
right.
point.
And just to, I think, just reiterate that it is like a line model analysis for slab.
Hmm.
So when we have those different strips set up, it looks at, the width and the reinforcement and the capacity that's, generated by that width. It'll look at the portion of the dead load and live load that'll go to that width, and then it'll analyze that on like a line model type of basis. So it's not like a 3D slab analysis per se. So just one other thing to note.
Any other questions? Sean, I don't know if you had anything to finish off with because we're a little over the time right now.
No, I think we covered most everything I was planning to say. As you noticed, we did multiple SKUs for a bunch of things. Pre-stress, we did single lane or single span instead of continuous. Um, so No, I'll let you guys go. And if you want to hang around and ask any more questions, I'll stick around for a little bit longer. But otherwise, thanks everybody.
Thank you all.
Thank you.